All right, this problem is also a conservation of angular momentum problem, right? So I have a merry-go-round rotating and a man is standing. So he starts standing out here, right? This thing is rotating around. He's out here, and then this man is going to walk to the middle. And as he walks towards the middle, the moment of inertia is going to go down, which means the angular velocity is going to go up because initial angular momentum has to equal final angular momentum. So I initial times omega initial equals I final times omega final. Moment of inertia times angular velocity has to be conserved. So again, I want to solve for the new angular speed, right? I'm solving for omega final. So here's my basic equation, right? I'm solving for omega final, which is pretty easy. I just got to figure out my moments of inertia, right? So just like the other one with the guy spinning, let's get your initial moment of inertia. So in both of these cases, it's the man and the cylinder. So the merry-go-round is a solid 63 kilogram cylinder of this radius, right? So for both of these, it's the I of the cylinder plus the I of the man, right? So for initial and for final. So why don't we just go ahead and find the moment of inertia of the cylinder, right? Moment of inertia for a cylinder is equal to, a cylinder is half mr squared. I don't expect you to remember that, but I could do half mr squared, right? So 63 kilograms is m, that would come here. 1.5, this is r, that would go here. Half mr squared, I could solve for the moment of inertia of the cylinder. And that number is not going to change, right? The man moving isn't going to change the cylinder. So this number is going to be some constant. And then I just got to figure out the moment of inertia of the man, right? So that's going to be the moment of inertia of the cylinder, which I will have figured out, plus the man is a point mass. So the man is going to be mr squared. So the man's mass is m, and however far he is r. So over here, when he's out here, 1.5 meters, that would be my r. And that would give me I naught, right? So I could get I naught. And then same thing, for I final, it's going to be I cylinder, which I got already, right? So I'm going to take that number, whatever I get, and that goes here, plus the moment of inertia of the man. So that's, again, he's a point mass, so it's mr squared, right? But I don't know if yours is as good as mine, right? It says my guy goes to 0. And if r is 0, that means this whole term goes away, right? So if your problem is just like my problem and it says the guy walks to the middle, that guy basically disappears, right? He's on the rotation axis. So this is 0. So my final is just the cylinder. And now I know my initial, I can put it here, and I know my final, and I can put it here, and I know my omega because it tells me in the problem. Where is it? Right there. Revolutions per second, right? If I want radians, I still got to convert, right? So revolutions, one revolution has 2 pi radians, right? So I can convert revolutions to radians, but that's not that complicated. And then you can solve for final, right? Multiply those two and divide, right? So not that bad. Again, just a conservation problem, but we had to actually calculate the moments of inertia of each little piece. And again, just like with everything else, it helps to write everything out in pieces so you can see it instead of just trying to do it in your calculator.